While some parts of software features are exposed, a lot of attacks depend on exploiting bugs in software. This triggers obscure and unintended behavior, which can lead to a compromise of the system running the vulnerable software. These types of vulnerabilities can be fixed through software patches and updates, which correct the bugs that the attackers exploit. As an IT support specialist, it's critical that you make sure that you install software updates and security patches in a timely way in order to defend your company's systems and networks. Software updates don't just improve software products by adding new features and improving performance and stability. They also address security vulnerabilities. There are some software bugs that are present in the core functionality of the software in question. This means that the vulnerability can't be mitigated by disabling the vulnerable service. Not good. An example of this was the Heartbleed vulnerability, a bug in the open source TLS library OpenSSL. This was discovered and widely publicized in April of 2014. The bug showed up in how the library handled TLS heartbeat messages. They're special messages that allow one party in a TLS session to signal to the other party that they'd like the session to be kept alive. This works by sending a TLS heartbeat request message, a packet that has a text string and the length of the string. The receiving end is supposed to reply with the same text string in response. So, if the heartbeat request message contains the text, "I'm still alive," and the length of 15, the receiving end would reply back with the same text, "I am still alive." But the bug in the OpenSSL library was that the replying side would allocate memory space according to the value in the received packet. This was based on the specified length of the string, like it's defined in the packet, not based on the actual length of the string. The value was not verified. This meant that an attacker could send a malformed heartbeat request message with a much larger length specified than what was allowed. The reply would contain the original text message, but would also include bits of memory from the replying system. So, an attacker could send a malformed heartbeat request message containing the text, "I'm still alive," but with a length of 500. Because the length value wasn't verified, this means that the response back would be, "I'm still alive," followed by the next 485 characters in memory. So it was possible for an attacker to read up to 64 kilobytes of a target's memory. This memory was likely used before by OpenSSL library, so it might contain sensitive information regarding other TLS sessions. This bug meant that it was feasible for an attacker to recover the private keys used to protect TLS sessions. This would allow them to decrypt TLS protected sessions and recover details like login credentials. This is a great example of a mistake in the code leading to a very high-profile software vulnerability. It could only be fixed through a software update or switching to a different TLS library entirely. While the heartbeat functionality is enabled by default, it's possible to disable it in the OpenSSL library, but it wasn't a simple argument to pass to an application. Disabling this functionality required compiling the library with a flag that was specified to disable heartbeats. Then you had to replace the installed version with the custom compiled one. That's not something most people will do. This was also a library widely used by both server applications and client applications. This means that it may not be possible to replace the OpenSSL library with a customized version or a different library. The only way to address the vulnerability in client software that implemented OpenSSL was to wait for a patch from the software vendor. What a mess. Here's the bad news. With software continuing to grow more complex over time, these types of bugs are likely to become more commonplace. Attackers will be looking for exactly this type of vulnerability. The best protection is to have a good system and policy in place for your company. The system should be checking for, distributing, and verifying software updates for software deployment. This is a complex problem when considering a large organization with many machines to manage that run a variety of software products. This is where management tools can help make this task more approachable for you. Solutions like Microsoft's SCCM or Puppet Lab's Puppet and Factor tools allow administrators to get an overview of what software is installed across their fleet of managed systems. This lets a security team analyze what specific software and versions are installed to better understand the risk of vulnerable software in the fleet. When updates are released and pushed to the fleet, these reporting tools can help make sure that the updates have been applied. SCCM even has the ability to force install updates after a specified deadline is passed. Patching isn't just necessary for software, but also operating systems and firmware that run on infrastructure devices. Every device has code running on it that might have software bugs that could lead to security vulnerabilities, from routers, switches, phones, even printers. Operating system vendors usually push security-related patches pretty quickly when an issue is discovered. They'll usually release security fixes out of cycle from typical OS upgrades to ensure a timely fix because of the security implications. But for embedded devices like networking equipment or printers, this might not be typical. Critical infrastructure devices should be approached carefully when you apply updates. There's always the risk that a software update will introduce a new bug that might affect the functionality of a device, or if the update process itself would go wrong and cause an outage. I hope you can see the importance of applying software patches and firmware updates in a timely fashion. It would be pretty embarrassing if you wind up being compromised by a vulnerability that could have been easily fixed with a software update.